Hi everyone, welcome back to my series on my senior year project, a personal pick and place machine. My name is Cole Hartley, and this is likely going to be my last video on my senior project, and that's just because I graduate in a couple of days. But nonetheless, I mean, it's not something to be sad about, as sad as that sounds. I have a lot of great news and updates within this machine. As you can tell, a lot has changed cosmetically, as well as internally within our firmware and configurations. We've actually done a lot of beefing up to our system. So I'm excited to run it through one last time and just kind of demonstrate to you guys all the new features. And then I also want to demonstrate what a full job would actually look like when using Tri.P. So I'm gonna hop in the computer and we'll kind of get started. Alrighty, now that we're in OpenPNP, the first thing that we're gonna need to do is actually turn the machine on. So I'm gonna show you what that looks like a little bit. So first things first is we're gonna come over here to this red switch. This is going to be our main power from our 24 volt Ender 3 V2 power supply. So we'll go ahead and turn that on. And you'll see that we have that neatly tucked in the back here behind our electrical storage unit, our ESU as I call it. Now, second step is going to be to turn on our buck converter. Now this is just going to step down this 24 volts to a voltage that is applicable to all of our systems. Now this is 4 channels. We have an array of voltages. We have 3.3, 5, 12, and then we have an adjustable voltage here that we have set to about 20 volts for our motors. So we'll go ahead and turn this on. There we go. Everything looks good. Now our final step is going to be connecting everything to our computer. So you can do this, you can connect it to any laptop, anything like that. So it's very friendly to everybody. So this first wire here was our USB wire to our motion controller. And then the second wire is going to be our camera cable there, which I'm very excited to show off. I don't think I've made a video on it quite yet, so very excited for that. All right, so now that we are ready to home the machine and get it ready for a full job, we will click this little yellow house button, and now this will start our homing procedure. And now I want us to pay close attention to our homing sequence. So we are going to hit a series of limit switches, which will set a mechanical 0 for our machine, which the mechanical boundaries of the machine are valid to change every now and again due to different bumps and bruises, you know, just very characteristic of a budget machine. You know, no limit switch is perfect. A lot of them actually have a sort of debounce issue as well. So this will set a mechanical 0, and then our machine will move to a predestined point, and at this point it will zone in on a marking, and you will see this more in depth in a second, but it will use a circular symmetry detection model to actually find this point, and it will deem this as our absolute 0 point. Or it will configure itself around this point and make that our 0. Hope that kind of makes a little bit of sense. But you'll see here that we are moving. You can see that we are hitting limit switches. And there we go. So the machine detected the 0, or the marking, and has now set this to be, or it has now refreshed the coordinates of the machine. So if we go ahead and hit park, you will see that we are now at a perfect 0, 0, and 0, and you'll see that the camera looks a little bit different. All sorts of things are happening here, but this is what we want for our job. Now we have a fresh coordinate system. Everywhere that we move within the machine is absolutely correct. If we were to move to our feeders here, we know that they'll be correct. There's no way, because they are calibrated with respect to this dot, if that follows. So let's hop into a quick little job and try to speed this up. So let's say I want to do my precision test board, right? So this would be a file that you got from a KiCad or some other circuit building software. So now that we have all of our placements within OpenPNP, you can configure your feeders, you can do all sorts of things. I actually need to grab a board and demonstrate our fiducial or our PCB updating, but maybe we'll do that in a separate video, or check the demonstration video that I will be posting soon. That has a lot of great information as far as our specs, different characteristics, all sorts of things. So definitely check that one out. So we actually won't go through that this video. This one I just want to do a quick overview and show you guys what all we have going on so far. So without further ado, let's hop into a little job, shall we? So you can see here that the machine is actually using the circular symmetry model to detect where the feeder strip is. So that way there is never any error when picking up any components. And of course I don't have any components loaded in right now, as we just had our competition the other day. So we actually ran through all of our boards and I have no boards to build. But let's see, we'll take this off the stand here. We'll run it through that job one more time for us. Yep. All right. Looks like we had a leftover resistor in there. We had a couple. There we go. And it will go back to its home position every time it finishes a job, making it very easy for you to pick up your printed circuit board after it is done being assembled. All right, so let's hop back into OpenPNP and I will go over just a couple of different things, some data that we have in there. All right, back in OpenPNP, just real quick, just want to note that here in the left corner, we have a little update from the machine. It says job finished without error, placed 8 parts in 35.1 seconds. Now that's roughly 4 seconds per part. And Tri.P can actually go much quicker than this. We actually have it set up right now on the safest setting where Tri.P will check each part in the strip. So every time it goes to pick up a part, it will actually look for that circular indicator on the strip. So on average, we can see up to about 2.5 seconds per placement, which would cut down that placement or assembly time almost in half, which is very good. Like I said, check out the demonstration video that I will be posting soon. It's the one that we submitted for our competition, and it goes over all of our details, all of our specs, our movement speeds, everything. So check that out for sure. It's been an absolute pleasure working on this project. If you guys have any questions of any sort, absolutely reach out to me. If you guys want to see anything be operated, I can definitely look through my demonstration videos and just them out to you guys, my configuration files, all that sort of stuff. Like I said, I'm graduating here soon, so I will not have access to the machine, unfortunately, as it is property of the school. But yeah, I mean, it's been an absolute pleasure building this and working with my team, my mentor. Huge thanks to all of them, as I'm happy to announce that our project Tri.P actually did win first place in this competition. And yeah, I just couldn't be more grateful, as a lot of time and effort went into this project. countless days, nights, all that sort of thing, lots of engineering, but it all paid out, and that's really what it comes down to is, you know, did you do what you said you were going to do? Did you give, you know, your customer, or in this case it would be the faculty, did you give them what you said you would give them, which Tri.P was everything that and more. So yeah, it's been an absolute blast making Tri.P with my team, my mentor, and yeah, thank you guys. Stay maybe updated for that demonstration video.